So today we've got John Sterrett. He is here doing a session, Performance Tuning in Azure SQL Database. This is our session for August 31st, 2016. We do have a number of upcoming sessions I want to make sure people are aware of. We've got everything from some Azure Data Factory to streaming analytics, Cortana intelligence, and even next week we're doing a session on Amazon Web Services for databases. So if you are looking for some cloud content, we do have quite a number of items that are coming through. And if you have something that you would like to present to us, please reach out. My name is Jason Sterrett, and you can reach out to me on Twitter or via email and get me that information. Just some community news to help everyone keep up to date with what's going on within the PASS community. So the first thing is that the PASS Summit is coming up here in October, at the end of October. There's going to be 200 plus technical sessions, hundreds of expert industry speakers, and just experts with SQL Server. Product team from Microsoft is going to be there. If you haven't registered yet, you can get a discount code. The discount code for our virtual chapter is VC15CHB6. So if you are looking for a discount that you don't already have, you can use that to get $150 off the current price of registration. Today is, for all intents and purposes, the last call for Passion Award nominations. The nomination deadline is tomorrow. So if you do know somebody who has been giving back to the community, whether it's your local user group leader, if it's a speaker that you've seen at a SQL Saturday, or just somebody that you've interacted with at PASS that has really made a difference in your career this year, or your networking, or has really helped you out, please nominate them. You can nominate the person by sending an email to passionaward@sqlpass.org. Just put in your name, the name of the person, the community activities that you worked with that person with, and what do you think their notable accomplishments are, and why you feel they deserve the Passion Award. This is a great honor for the people that do receive it, and so I encourage people to really reach out and help those people that have helped them. Coming up here on September 7th as well is the preview for PASS Summit sessions and speakers, and 24 Hours of PASS is coming up. If you haven't already, please go out and register for some of those. There are sessions that are going on for 24 straight hours. This virtual chapter is like many other virtual chapters, and so there are meetings that are coming around all the time. We've got the meetings that I mentioned that are coming up for us, but then there's also sessions coming from Global Spanish, Data Architecture with Kimberly Tripp, DBA Fundamentals with lessons learned on very large databases. If you are looking for some sort of information on SQL Server or some sort of training, whether it's by discipline or by language, there is probably a virtual chapter out there that can help you. Lots of the virtual chapters are always looking for people to reach out and let them know what kind of content that you're in need of. Reach out to them and find out if they can find a presenter for you on that topic. Similar to virtual chapters, there is the SQL Saturdays where you can also get free training. SQL Saturdays are going on pretty much all over the world all the time, whether it's in the US, Canada, Asia, Europe, or Latin America. There are SQL Saturdays that you can go to with basically free training. Usually you have to pay for lunch, but outside of that, it's completely free. And so it's time to get started with things here, and I will turn things over to John Sterrett here. So let me make him presenter. All right, John, you are now presenter, and the floor is yours for performance tuning.
Thank you, Jason. Are you able to see my screen?
Yep, I can see it. It's coming through perfect.
Great. All right, well, today we're going to be jumping into performance tuning with Azure SQL Databases out in the cloud here. So a little bit about me before we get started here. I am a MVP, also certified on the latest certification. I also run my own business and do a lot of performance tuning, stabilization, and high availability out in the database engine as well. And I'm a blogger, presenter, author. I've written ran one of my friends, also an MVP, back up in recovery. And like Jason, I'll also be going out to the Task Summit here, and I'm looking forward to that in October. So I'll be speaking and also just catching up with my SQL family out there as well. So today's objective here, briefly, we're going to cover some things that you most likely are doing or should be doing if you are going to be doing performance tuning with an on-prem instance today. We're then going to cover over some things that you are doing or should be doing there that will work really well with you out with Azure SQL Database. And then we're also going to touch up on some things that you're going to want to do different over there as well. So starting off here, we're going to go ahead and talk a little bit about performance tuning with your on-prem instances that you have. And so starting off here, we're going to talk about some of the resource bottlenecks that you typically see. So for example, the first one out there would be memory. And you want to make sure that you have memory configured correctly because SQL Server is a great caching application. If you tend to not have memory set right or enough memory, you're going to see a lot of disk utilization there. So you kind of want to focus on memory before you start net disk, because if you just look at disk, you can see issues there that you may be able to fix by just having memory configured right. And then also you have CPU as well. So as things are needing to run, then we need to be scheduled and get a task and be able to run as well there. So usually you're going to have network activity as well. Data is going to be sent from SQL to the client back and forth. So that's another resource that you want to look at. And then also locking, blocking, and deadlocking as well. And quite a bit of this is going to translate over to Azure SQL Database. We're just going to kind of look at it a little bit differently than how you're looking at it today with your on-prem instances. So what do we benchmark in the on-prem world? So there's quite a few things. Here's just a good subset that's kind of the 80-20 rule of most of the stuff you're probably going to want to be baselining and looking at. So the first one is weight statistics. Main reason why is this is a helpful resource to help you eliminate a lot of things. It doesn't exactly get you right to a smoking gun or a root cause, but it's one of the quickest things I tend to use to eliminate a lot of things. So if you see disk issues, then you're probably going to want to look at disk latency. So in this you can pull from perfbot or also from the DMVs as well, and you can aggregate that and go to exactly which data file, where it's located, how much latency you're seeing there if you're having some disk contention. So while that's going on, you're going to want to be able to benchmark your SQL statements, and then you can kind of loop this back to, okay, what statements are our top offenders that are causing our resource contention? And maybe in there's some indexing work that could be done, or maybe rewriting the code to be a little more friendly to help you with your bottlenecks there. So with indexes, that's where you can look at your index usage stats, recommended indexes that you might want to apply or end up tweaking your indexes that you currently have to cover multiple statements. And of course, there's a million things that you can look at with perfbot as well. So there's a little link I provided at the bottom of the screen there, and I'll have it on the last slide of the presentation as well. Quite a few years ago, when I was one of the performance tuned leads at Dell for the Dell.com databases, I kind of built a nice little methodology and I blogged it all out so you can get the code and exactly the thought process and stuff there if you want that as well. So we talked a little bit about weight stats, and here are some of the top weights that we want to focus on to look at what resources are having some contention here. So for example, with disk, you'll have page IO latch. So this is basically reading a data page out from disk into memory so it can be used. Where write log would actually be for data that's changing and hardening those changes to the log. We're going to cover this quite a bit here because these are two different huge factors for a measure called DTU, which we're going to get into a little bit later. So CPU, so same thing. We have SOS schedule yield, which basically means that this query that's running needs more than 4 milliseconds of CPU time, so we're going to throw it back to the queue so we don't starve SQL from allowing other processes to run. And in memory, you can see there that we have latching and page latch as well. So how do you monitor performance with on-prem? There's quite a few tools that can help you get this done. And quickly we'll focus on some of these here and talk about how they translate, or if they don't even translate, to where you can use them out in Azure SQL Database. So the first one is DMVs, and this is something, you know, we could talk about forever. But the good thing here is a lot of the DMVs are going to work for you out in SQL Azure. There's a couple that you're going to want to tweak on how you're using them, or you may need different permissions. So for example, if you want to look at requests to see what's running right now, we're going to want to make sure that you have view state in the database for that out in Azure. Profiler, so this is a great tool that you could use to, and with Profiler, when I say that, I also mean server-side trace, so that way you can see what's going on in your current environment and correlate that with perfmon data. So at the same time, you can do extended events. There's a lot of great things that you can capture with extended events. And also, you can jump into query storage 2016, which we'll get into a little bit here as we dive deeper towards the Azure side. And then if you want to just get some good recommendations, you can use the DMVs or even Data Tuning Advisor, and we'll talk about how that converts over to a separate tool out in Azure as well. So very high level, how do you improve performance once you've kind of figured out your bottleneck, your resource contention? You can either increase your resources, so if you're out in a virtual environment, this can be a little easier if you have resources available, you can get them added to your VM. But if you are using physical boxes out there, you have to go procure and get a new box. So you better be right on what you need, because if you're not, then you need to end up spending more money and take a longer time to get the resources, get them in your environment, be able to start using them. We'll see in Azure how this is lightning quick to where you can easily run a query or go through the Azure Portal toggle and switch instantly the performance level that you'll use. So instead of waiting weeks or months, you can easily make that change if that's what you want to do. At the same time, you could reduce your workload. So for an example here is maybe you have a real chatty app that has a lot of small calls going back between the app tier and the database. Maybe you can work to make those more of a set-based activity, so you have a lot less activity going across the wire. The third one here, which is where a lot of focus will tend to go to with performance tuning people, is improving the code or the actual design of the schema. So now let's focus, now that we kind of went over, spent a good little bit about time over what we do in on-prem world, now we're going to go over to benchmarking out in Azure. So the first thing you should notice here is we have less things that we're going to go after and benchmark. So one of the benefits for database platform as a service is there's less knobs for you to go out and physically tune or turn. So this is a good thing and also a bad thing, meaning you have less things that you can physically do, but it also will help narrow your scope, which could be a good thing. So we're going to talk a little bit about DTU. This is kind of your foundation of benchmarking, your starting point out in Azure SQL Database. So we'll go over exactly what is a DTU, how do you calculate it, and how can you easily pull that data if you wanted to get that from T-SQL so you can do your own analysis and maybe automate a process to where you could actually scale up or scale down your data tier on how much DTUs you're able to use. So at the same time here, we'll take a look at weight statistics out in Azure SQL Database and how you're going to want to do this a little bit differently. So we'll go over and show you that. I'll also show you some very specific weight types you're only going to see out in Azure SQL Database that can be very helpful for you. So we'll show you a couple different ways on how you can get through your SQL statements, whether using the Azure Portal or you're going to be using Query Store or DMVs. And then we'll also look at indexing a little bit, because if you are going to go out and make statements run better, you're going to be limited to really focusing on indexing and changing your SQL statements. So we'll dive into that stuff as well. So the first thing here, we're going to go over into calculating DTU. So before we can even calculate DTU, we're we're going to need to figure out what the heck really is DTU. So DTU basically now stands for, this has changed, but right now it's Database Transactional Units. So when you think about how you're probably doing baselining today, this is going to be really confusing to you, mainly because you're used to fixed resources, right? You're actually used to looking at IOPS or disk latency, or you're used to looking to see, you know, how much memory is physically available or being used. What's your page life expectancy? So here we're going to combine a whole bunch of things into one metric called Database Transaction Unit. And below here I have the definition coming from Microsoft's documentation. And to me, this is extremely confusing. So when you look at it, it's basically saying it's a real-world measure, which is a database transaction. So we kind of know what a database transaction unit is here, but to me, it's very fuzzy seeing what actually is a database transaction. Are we talking about every single transaction that's going through, or a combination of metrics? So as you can tell by now, if this is your first time going through and you don't physically know exactly what DTU is, you should have some questions. I know I sure did. In fact, I even posted a question out on AskSQLCentral.com, and no one answered it, so I digged in and found the answer, which we'll get into a little bit here. But basically, if you go to the Azure Portal here, you could look and see, here's our DTU calculation, here's where it's going. So we still don't really know exactly what it is, but we know we can kind of baseline it and track it and maybe make decisions off of it. So this comes down to what really is DTU. And I have a link down here which goes into exactly how I found it, the queries and everything that's used in it. But to kind of make the story short here, I wanted to be a detective. So I kind of wanted to think, you know, how would I go out and I would find exactly how DTU is calculated, so that way I don't have to just be fully reliable on the Azure portal and looking there, and I could actually use T-SQL to pull this data. So the very first thing I did was I realized, okay, there's a couple of DMVs, and we're going to jump into those, that actually have the data inside of them. So the first thing is I can easily see where this data relies if I want to pull it from a query. So I still don't exactly know how it's pulled, and I'm able to find that by actually using Query Store. So I actually used Query Store to figure out the queries that are used to pull out. And like I said, the link there gives you all that. But here it is at a very high level. We basically have a DTU percentage. So this basically is a percent of combined resources, or in reality, it's actually the max resource. So whatever is the highest between CPU, log usage, log writes, or reads, times our actual DTU limit. So for example, if you're out in S0, this would jump out and it would be 10 for you. So here basically is some of the meat of the data that was taken out of the query that was pulled from Query Store. So here you can see it's a max value, and then we have a couple of values that we're going to get. So one is the CPU percentage. One is data IO, the reads that are going on there, and then the writes as well. So writes for your log. And basically whatever the highest value out of any of those three is going to be your exact DTU percentage there. So then calculating DTU, once again, right, it's our limit, and we're going to go ahead and times it over there and then divide it by 100 to actually get the DTU from the percent there. So now we know how to actually physically calculate DTUs. We're going to talk a little bit about those two views that we're diving into to get the data. So the very first one is going to be DMDB resource stats. And so this gets you basically data that you would query this view inside of the user database. So it's going to collect and aggregate data for you every single 15 seconds. And it's going to go ahead and keep that data for just 1 hour. So if you're going to want to pull data from there, you're going to make sure you want to get it before the data gets purged. Another thing to note here is if you have idle activity, so nothing is actually going on inside of your environment, we'll still keep data in here. So the second one here, this is for longer term data, and this would actually be in the master database itself. So in here, this is going to collect every single 5 minutes, and it's going to keep this over a period of 14 days. One thing to note here, though, is if you actually have an idle interval where a database isn't used, for example, for 5 minutes, you may not see rows for that time period. All right, so here's an example of the data that would come out. So here we're looking, we can see our DTU limit in this case here, that it is 10, so we're in S0 as our performance tier. Our average DTU percent here we can see is in the 90s there. And basically by multiplying those together, dividing by 100, we'd get the actual DTU that's being used during that time interval. Now I'm highlighting over here those 3 metrics that are used where we basically just take the max value of these 3 to figure out our DTU percentage. And the reason why is because another column that you can see there, for example, is average memory usage, and it's not part of the calculation. So even though it may be higher, it's not one of the 3, so it's reference information for you, and it's not used currently to date for calculating DTU. All right. Jason, any questions that have came in?
Nope, no questions yet. Sorry, I was double muted. Nope, no questions yet.
No worries. All right, so we'll go ahead now then. Now that we kind of have a good understanding, and I wish I should have had a poll question here to ask how many people know what DTU is and what do they think it is, because it's something that's not that quite easy to figure out. But now that we know that, now we can jump into the next thing that we'd want to look at, which would be our Azure weight statistics. So basically we have another DMV here that we want to focus on. So instead of focusing on what we would normally use out in the on-prem world, the sysdm OS weight stats, we're actually going to have a view under our database. So it would be sysdm db weight stats here. And this is what we want to collect on because our database is in a shared environment. There are going to be other databases out there that we don't want to calculate metrics for them because we have no control. There's absolutely nothing we can do to do actions based on those weights. So we just want to focus on what's inside of our database. And we talked about DTU, and I mentioned that first because we have some specific weights that we want to focus towards DTU usage. So for example, under disk usage for doing disk reads, one of the reasons why you didn't see me throw out there that we want to capture our disk latency is mainly because that's going to be a non-issue to you because you're going to be throttled well before you start consuming and risking I/O that's going to jeopardize I/O for other consumers out there in your resources that are being shared for your database and other customer databases. So we have this weight type here called IOQ limit. And basically what this does is it's going to capture weights that are going to happen whenever asynchronous IOQ for Azure Database has too many IOs pending that's outside of its DTU range. So basically, in order to guarantee to stop you before you start really hurting disk usage, you would see IOQ limits there. So the next one over here is for transactional log. So let's say you're doing a big migration, you're moving a bunch of data across, you're doing some big ETL. One thing that you'll end up seeing there before you start generating physical contention out on the log drives that could hurt other users, you'll see log rate governor. And this basically is just going to pop up when you're waiting when you filled your quota that you have based on your DTU usage. So the next one over here is for CPU pressure, and this is going to be our same good old SOS schedule yield over here. But these are 3 counters. When you start seeing these, this is how you know you're really being pushed up against the limits that you have, and you don't have other weights like page IO as an example that's contending you from getting your work done. So once again, there's a link down there, and I'll have the link on the last page as well, which goes through my query that I have that I use to sample this data that you can pull, and we'll have a demo that goes through this as well. And in fact, here's just showing you a screenshot of some of the results that you would see. So we talked a bit about being throttled, and then here are some specific examples of showing that you being throttled here. So here we're looking at two things together, and this is going to be our weight stats that I'm collecting for my database. And we can see here that we're having quite a bit of schedule yield, so CPU pressure. And then we're also looking at our DTU query here at the same time. So here we can see that we're right up against our limitation here. We're right at our limit of 10 here. And our huge driver in this case is CPU, which is explaining why we're seeing SOS schedule yield. So if we're in this scenario, this is a case where we definitely want to find our top offender statements for CPU and start seeing what options we have for reducing our CPU usage. Or maybe consider improving our performance tier, moving it up so we get more DPUs to work with. So the next case here, we're going to go ahead and look at IO throttling. So in our IO throttling here, we have both cases here. One where I'm actually bulk inserting about 60 gigs of data across here, and we're being throttled by a log rate governor, which basically is saying, hey, you're trying to use more log than you paid for, and we want to keep everyone fair in their areas that they've paid for. So instead of actually seeing a lot of write log contention, we're being throttled based on our queue for doing log writes there. So the next one is for reads. So here I have a query that's running that's doing a full scan across a very large data set, and because I'm on standard S0 tier for collecting this data, we are exceeding our queue that's allowed for us to read at that time. So there we can see throttling from both the write perspective and also from the read perspective as well. All right, so the next thing we want to take a look at, now that we've kind of seen what our resource contentions are, what are some things that you can do inside of Azure SQL Database? One of them is indexing, for sure. And this is going to be pretty similar, in fact, mostly exactly similar to what you would do on-prem. You could find your index fragmentation and run whatever process you would have to fix your fragmentation. For everyone out there that's using OLA, you can still use OLA Halagrad's maintenance solution. It will work. Of course, the one big difference is how you're going to automate kicking off that job, or that process. You know, obviously you'd use SQL Agent, but you don't have a SQL Agent out in Azure by default. If you wanted to, and a lot of people do this, they'll have a small little on-prem, they'll have a infrastructure as a service VM that they'll use that they'll have a SQL agent use, but you don't have to go that route. There are quite a few things, whether it's Azure Automation, Azure Functions, or even App Service Web Jobs that you can use to kind of kick off those automated processes that you want to keep going. So at the same time with benchmarking, you're probably going to want to be looking at missing indexes, whether you're going across just the DMVs, or if you want to scrape the plan cache and be able to find, for example, all the plans that are out there, which ones in the execution plans do we have hints for recommended indexes. You want to look at index usage also as well, so you can make sure you have the right indexes. Maybe your code has changed or your data access has changed, and you may want to switch those as well. All right, so with that, let's go ahead. We're going to jump into a quick demo here where I want to focus on weight stats and DTU to show you exactly how you can get that information while you have a working workload that's going on. So with that, I'm going to pop over to Management Studio here. And for today's demo, I wanted to have a good set of data, but I wanted it to be pretty basic that anyone could grab or use. So I actually followed a good idea that I saw from Brent Ozar of using Stack Overflow since they've made their data openly available. And basically, I've thrown about 60 gigs of it out into an Azure SQL database. And this is just showing you the row counts there. And we're mainly going to be focusing on the comments table today, and you can see that there's over 65 million rows in there. So we've got a good set of data there. So the very first thing that I would do, and this is currently running, is I would have my process that runs to collect my weight stats. And this is for the database. Remember, we're going off of the new DMV out there that allows us to get this for our specific database. And the nice thing about this query that runs, and the link is provided so anyone can grab and use this if they want it, it's going to run, and basically what I'm doing is I'm doing two samples. So I'm going to take a sample, I'm going to wait. So the second parameter, wait seconds, is basically saying let's just wait 60 minutes. We'll run and grab it again, and then we'll get the difference and we'll persist that data. So you can change that as much as you would want for your specific environment, and then the end time there is basically how long do we want this to run. So once this data is persisted, and by the way, like I said, I just have query stress here. I'm randomly pounding some workload. So I'm randomly doing inserts, updates, and selects across the comments table there. So running these two together here, we could go ahead and look and see, okay, over interval here, what are our top weights? Are they actually resource or signal weights? So are we, sitting in the queue waiting to run, for example, SOS schedule yield? Or do we have other weights that are going on? And it's nice to kind of correlate these two together between actually looking at the weights and how long we're waiting per our intervals here, and also looking at the DTUs. So we can jump in here and see exactly where are our top offenders here. So for example, we're having a lot of CPU pressure, a little bit of I/O, but CPU is definitely our top resource here that's contending, causing our high DTU number. All right, so with that, we'll flip back on over here. And now we're going to talk about some performance tuning tools that you can use out with SQL Azure. So we have a couple here that are listed. One is Query Store. So this is something I highly recommend you use because it's also going to be a driver for some other tools you can use as well. For example, there is a tool out in the Azure Portal that I really, really love called Query Performance Insight. And one of the reasons why I'm a big fan of it is I have a nice graph that's being populated for me that's also showing me my DTU, which queries are running that are my top bottlenecks, and how much of the DTUs the queries are using at that exact time as well. So it's a really nice tool out there on the portal, so someone can have access to that, and they don't even have to use Management Studio to jump in to see what's going on. But a requirement for that is you got to have Query Store going to pump the data. So we can use that. We can use DMVs just like we normally do for the most point. There are a couple of exceptions, like I've mentioned two already, that I'll repeat again. If you're going to look at weight stats, you want to use the DBU DMV, not the general OS one. And then also one of the basic ones, so sys exec requests, you'll want to make sure that you have view state in there, or you're only going to see your current SPID. So if you're giving access to other people and you're restricting that access, if they or a tool is going to be pulling that data, you want to make sure that they have the right view state access for that. So the next one is extended events, and our host Jason has a great blog series where he's gone into a lot of details about extended events and great things you can do with them. And you can still do some of that great stuff out in Azure SQL Database, although there are some things to know. For example, if you're used to using extended events and you're using them in 2012 and beyond, you may like the graphical interface and how you can see live data. You're not actually going to be able to do that. You're going to have to actually use the queries to go against that data. The other thing to point out here is if you are actually going to look at data that you want to persist, so you want to actually store it to a file, this is actually going to need to go out to blob storage here, and we'll have hopefully a demo at the end if we have some time to go over that. But you have your Azure Portal, which is where most people start, which we're going to jump, and you can see the little graph of what's being used in DTU, and you can go from there to the two other tools that are quite interesting. One, my favorite, Query Performance Insight, and another one that's interesting, especially for people that may be using Data Tuning Advisor, is there's this auto-tuning index functionality to where, based on your access patterns and data that it's collecting, it can go through and recommend, but not only recommend, but automatically implement indexes for you. At the same time, there's an open preview that would give access to remove indexes automatically for you as well. That one's a little interesting. I want to see how that plays out because data usage patterns are always changing. So you may have some CEO queries that could be impacted by that, but I'm curious to see how that gets used. So the first thing that we'll look at here is Query Store. There's a lot of presentations over this, so we won't go into full in-depth, but there's a couple things I want to point out here for our workload that we have running. So let me pop over here. All right, I'm going to jump over to, we have Query Store enabled. And here we can see here that we have some reports that we can look at. So the very first thing I'm going to do here is I'm just going to look at overall resource consumption. And this is basically going to give us what resources are running and what type of contention that we're having in here. So for example, if we want to focus on duration, in fact, I'm going to focus on CPU because we already know from the data we're looking at, this is kind of our big reason for our high DTUs. So a couple things that's going to stand out to us here is we easily have access to our top queries that we'd want to focus on to get the best improvement here. So we can easily dive into those, and we see some pretty basic statements in here. For example, we're updating a column based off of a ID value that we would join across to the post table if we wanted to get the actual post that has comments on it. So same thing over here, we're running a query here where we're just getting, so we want to select all of the scores, the text, and the user that made the post over there on a comment. So the interesting thing that we're going to see over here, if you look over on the right side here, we have execution plans, which is what we're seeing down low here. The interesting thing here is we can see in the morning here, this actually is pretty good, but then there was a change that occurred, and now we've changed plans and we're kind of seeing CPU go up quite a bit here. So if we wanted to, we can easily select both of these, go over, and we're going to want to compare these. And we can kind of get the before and after here for our plans and see that we were doing an index seek, and now we're doing a clustered index scan. So in this case, we also have a missing index recommendation, which is basically the index that was here before. So in this case, we have an index that was removed. Maybe we had a code deployment change, and for whatever reason, something in there wasn't tested as well, and for whatever reason, we wanted to change our index, and now we're seeing worse performance. So we can easily get the difference there. The one thing we're not seeing in here, which we'll see a little bit later when we look at Query Performance Insight, is how much DTU is exactly being used by each individual query in here. So this gives us some good insight here. Another report that's definitely worth taking a look at is our regressed queries. And so what this is basically we're going to go ahead and take a look at two time intervals. So if I go over to configure here, I'm going to zoom in. We can look at what resource we want to focus on, but also there's two different time intervals. So recently, what's running within the last hour that has changed from a performance standpoint compared to everything up to last week? And so once again, our code release here where we removed our index here is showing us that we have quite a bit of a difference in performance here. So another reason why I did this is because I wanted us to kind of track and see if we can force some good index recommendations through the index automation functionality that's provided out there through the Azure Portal. So like I said, there's a lot of presentations out there that are going into this tool in great detail. I just kind of wanted to show some basics here on how this can be very helpful for you to solve some problems that were pretty hard before you had Query Store. So jumping back over, the next one we're going to take a look at is Query Performance Insight. So this is a tool that comes out through the Azure Portal that's going to show you some of the stuff that you see in Query Store. And maybe when you take a first glance at it, you're going to say, okay, this is great, but I kind of like Query Store just a lot more, and I'm going to use that because I can see the plans, I can see when plans change. The nice thing here is you get a lot of good information about DTU on a query level. So we're going to go ahead and we're going to jump over to the Azure Portal. All right, so here I have my resource here, and I got two databases out here. The one that we're mainly going to be focusing on today is Stack Overflow, and I've bumped that up from standard, so we're in the premium tier, and we're doing P1 there. So the very first thing you'll notice when you go out to the Azure Portal and you select your database is the fact that you are going to have some built-in monitoring in here. And I've tweaked this a little bit. There's two things I always like to see. One is how much DTU is being used, and what is the actual limit. And the reason why I want to see both of these two is because here, oops, I accidentally clicked on alerts, kill that. And then I'll zoom in on this. We're going to see two things here. One, we were running down here at S0, which means we're limited to 10 DTUs. Where this morning when I started running the workload again after I did my bad code release and accidentally dropped indexes that could be helping us, we bumped up to P1. And this is showing you our DTU usage across quite a bit of workload that's been running throughout the day here today. So one, I can look at here and see physically, okay, how much DTU is being used, but then I can also compare that across what our actual limit is. And the reason why you'd want to do this over a good amount of time is then you can kind of also look if you have a constant kind of line or peaks and valleys of DTUs that's being used, and you've had a scenario like this where performance went bad and you need it to be fast, so you bumped it up, you can look at this data and then decide how to bump it back down. But now that we've kind of looked at the very first thing that most people are going to see, and usually this starts the question of what really is DTU, which we've already answered, now we can focus more on performance here, which is what our presentation is about today. So the very first thing that you may want to jump to is Performance Overview. And this basically is taking the two features we've talked about, auto-tuning, which right now is just for indexing, and also Query Performance Insight. So I deleted the index hoping that the workload would force us in here to have the recommendations to add that back in there, but I'm not seeing that in there. But a couple things we'll first go over is the Query Performance Insight here. So we'll focus just on it so we can get access to some more knobs within this tool set here that's provided in the Azure Portal. So very first thing right out of the bat, we're going to get the last 24 hours, and it's going to give us our top 5 CPU consuming queries. Now lucky for us, and we can easily see this by looking at DTU in here, is that actually CPU is building, and now it really is our top consumer here. So if you see a big gap, like for example here, I want to focus on, we have our DTU up here, but only our CPU is down here. This is telling you that our data in between here is actually I/O related, whether it's reading or writing out to the log. Unfortunately, at this point in time, we don't have details specifically for I/O. We only have CPU in here, but you can see the difference there. And that's hopefully something that will be coming down the pipe soon. But right out of the bat, if you want to change what you're viewing, you can do so here by looking at the custom options. So for example, if we just wanted to focus on duration, so what's running along, we can easily do that by flipping the switch here. In fact, we can even say, let's just focus on the last 6 hours. And that's going to repopulate our graph. Now, our DTU line is going to go away here, but this will allow you to focus directly at, okay, what are the queries that have been running, and which ones do you want to focus on if you want to reduce total duration. So we have our same option for execution count. I'm going to go ahead and flip this back over to CPU here, because that's going to allow us to get our nice DTU line here. And we're going to look here and we can say, okay, there's some queries here, mainly 2, that's driving a lot of our pain here for CPU. So we're going to go ahead and take a look at them and see what good stuff can we find from our Performance Insight tool here. And right out of the box, you're going to get to see, okay, exactly what query is running. And you can see exactly here how much the total DTU is. So the red line here, this is the total DTU for everything that's running. But then once again, while we're looking at CPU, you can see how much CPU for this exact query is running, and also what is the total DTU. So once again, I'm going to go ahead and zoom in here, because we know that this query at this point in time is utilizing 78% of our total DTU that we have available to us. All right, and the other thing that we can see here is that the majority of it is CPU related. So once again, zooming in here for the CPU related, you can see that here by, you can see that here by looking at DTU and then CPU for that query as well. So same thing down here, you're going to get duration and the execution count. So you're kind of going to get all 3 metrics that you can go off of here for your individual query. And then also there's going to be some interval data that you can see there exactly how much resources were used during those time intervals. So that's pulling it from Query Store. So from there we can hop back and I want to go ahead and close this down. So we can do the same thing over here for any of the other queries. So this is a real nice tool that can let you drive right in to see queries that are pain points and exactly how much of the DTUs they are consuming. So pretty cool stuff there. This is just another example for us as well. So now that we looked at Performance Insight, the next thing we would want to look at is performance recommendations. And I was hoping that we'd get our indexes plopped in here, but I do not see it in here. So I'm going to go back over to our overview so we can look at auto-tuning, because this is another pretty interesting concept. So there's 2 things currently out there today that you can do with the V12 database, which is the most current version of SQL Azure Databases. You can tell it to create an index, so while it's building index recommendations, we can look at that, and we can tell it automatically implement them if you want. The other thing that's out there in preview, which is interesting, is you can do the same thing so it can drop indexes for you. All right, so we're going to go back to our, and we mentioned there, our auto tuning. So improving performance out in Azure SQL Database. There's a couple of options for us. So one, the easy one, which I kind of showed you that I've done today as an example, which a lot of people are doing because it's the easiest to implement, is just change performance tier. So for example, I went from S0 to P1. Now this doesn't really scale that well, and the reason why is because you're either going to run out of money or you're going to run out of tier options. So while it can be an option, it's one that definitely won't scale as you keep hammering and throwing a lot more workload at it. So as always, you can tune your top offender. So in this case, I have some indexes that we would run that would dramatically reduce the time that these queries are using. So the next one I see out there a lot, I'm working with a couple of clients through this right now, is what I would call chatty database activity. And this is basically the app tier is having a lot of database calls back and forth from the app tier to the database. These can be real small, like, in a way it's kind of like row by row processing, where for each individual row, we're going to send data back to the app, do something, and go back and forth through the whole set. So changing that into more of a set process where you have a lot of less hops between the app servers and the database can be very helpful. So another one, and this goes back to reducing your resources, is app tiering, or application tier caching. So if you have statements that are pretty much going to be the same for quite a bit of interval, maybe we want to look at some options for caching those. And the last one, which tends to be a pretty big architecture change for existing applications, would be what we would call sharding data. And this is basically scaling out instead of scaling up. So having multiple databases for our data, which we have subsets of data in that's grouped together. So performance made easy. This is our example of increasing our performance tier, where it could be as simple as writing a T-SQL statement or going to the Azure Portal and changing your performance tier like I did this morning from S0 to P1. Run our workload, so if we're doing a big import, or we have a big set of reporting queries that we know we're running, we can change that. And then once that workload is done, we can drop it back down to save money. So here's an example of importing their data that I did to kind of go over migrating an existing database out to Azure SQL Database, moving the StackFlow data over. Here we're going to see where basically I'm running over a day, and you can see I started out at S0, which was 10 DTUs, and bumped it up to 20. The end over there where you see the line going back down isn't the process finishing, it's actually giving up because of seeing how much data is moving and noticing that it's going to take a very long time. So I did a second attempt here where I just instantly put it to P1, and we can see here that during the import process I'm hardly actually hitting that threshold because of my limitation of sending the data out from my own environment box out into the Azure SQL Database. So the big point here, if you're going to be moving data, one thing that can be very helpful for you is just instantly bump up the tier to the highest that you can, do that work, and then once it's done, drop it back down. And so here's an example of some of those weights that I was seeing throughout that process, where you see quite a bit of log rate governor, which just means because of the low performance tier, I was being throttled on my writes. And with that, that is pretty much the presentation. As I promised here, I have quite a few links that I went through that will get you a lot more information and some queries and stuff that you could be using. And then, of course, my contact info is down here at the right. I think we still got about 5 minutes or so. So, Jason, if there's any questions, let's shoot, and hopefully I'll be able to answer them for you.
Hey, John. Right now there are no questions in the queue. Looks like you answered everyone's questions as we were coming through, so nobody had additional questions to ask.
Okay.
Oh, actually, here we got one that just came in. So we got
okay.
some time to fill in. Are you using X events?
Oh, yes. Yes. So as I mentioned, and we kind of ran short a little bit of time, so I didn't get to fully jump into it. I can just show the quick little process of it. But yes, and the way how I use them, because I want to persist the data that I'm capturing, is I'm using an Azure blob storage. So let me go over just real quickly here kind of how that works. So if I go over and I go over to, let me pull up that, move this. go to. So in order to create it, basically I have to set up my certificate that's running. That would basically have my Azure Blob Storage key that I would end up using. But at that point, once you have that in place, so here's just a basic one where I'm capturing any case where resource stats is running. But as you're creating your event, once you have your certificate and everything in play, your target then would just be your blob storage out here, the container name, and then the file name that you would want for it. And then, of course, you would stop it here. And then, of course, you can use your typical queries that you would use to kind of parse through your XML to get the data back that you would want here. And, of course, the other thing to just quickly highlight here is while it would be really nice to view this data, with the live data viewer, it's just not there, which is why we have to do it through T-SQL.
Okay.
So I'll blog more and put something out there for people to see on that.
Great. Well, there aren't any more questions, and we are right up to the time limit here. So, John, thanks again for the presentation today. We will get this presentation posted up to YouTube so people can watch it after the fact, and look forward to hearing from you again in a future presentation. And everyone else, next week we'll have another presentation on, this time I believe it is Amazon Web Services with SQL Databases.
Sounds great. Thank you, Jason.
Yep. Thanks, everyone, and goodbye.